Hello, hello, hello. Hey, Julian.
Hey, Eric, how are you? The both of us together. We don't often do this.
We
I
don't get to
know.
do this very often. Yeah. Hey, thrilled to be here. Hey, if you're watching out there, thrilled to have you as well. This is Serverless Office Hours. Today, Julian's going to be killing it on one of our latest feature releases that's just gone GA. We'll get into that. I don't want to, we don't, although it's in the title, I don't want to, throw it out yet. So. But Julian, how's life for you? How's things over across the pond? I like to say across the pond.
Yeah, life is really good. People are getting vaccinated. Hopefully, we're moving in the right direction from that perspective. There is a massive, big football / soccer, whatever you call it, in different parts of the world game tonight. It's England versus Germany. So I know my colleague Ben has got pizza and beer in front of the telly, and probably the rest of England. But I'm South African, even though I live in London, so I'd far rather be doing serverless office hours.
Okay.
And it's much cooler. Isn't that what it's called?
No, I don't think feetball is ever one of the. I think sports ball would be better than feetball.
Okay. I thought you played it with both feet instead of just one foot, so that's why.
Yeah, okay. All right. I think we better get to tech before we embarrass ourselves further. So, all right. So if you're not familiar with this, is Serverless Office Hours, and there we go. There we go. Serverless Office Hours. We do this every week, 10 a.m. Pacific time. If you're catching us from across the pond, what time is it there, Julian?
Yeah, 6 p.m. UK time, and it will be 7 p.m. Central European time.
Okay, big soccer game. Feetball game. So, and then telly, for those of you who didn't follow that, is television. Just so you know. So throwing this out here. All right, so here's what's going on here at Serverless. We have all kinds of things. This is Julian Wood. Tell us about yourself, Julian.
Yeah, I don't look like that at all. That profile picture needs some longer hair. That's what happens with lockdown. But yeah, it's awesome. Basically, Eric and I are on the same team. Eric's in the principal office. I'm just in the seniors mess lounge. But yeah, we're part of the developer advocacy team here at AWS, specifically focused on serverless. So yeah, I live in London, originally from South Africa. I don't have as many kids as Eric. I've only got 2, but they are twins and they are cute girls. So I'm going for that as much as I can do.
They are cute. I've seen them, cute girls. You can tell I have more. I have 5 kids. That's why I have no hair. So I'd rather not hear you complain about your hair. So whatever. Next up out there. My goatee is no longer nearly that dark. I was watching a video of myself from 2 years ago. It was a dark brown goatee. 2 years. So
is that what this job does to you?
Yeah, exactly. That's called parenting right there. So let's talk about last week. If you missed last week, we had Newton Jain, Anant, and Vadim joined us, and we talked about serverless surprise. We talked about machine learning on AWS Lambda. If you missed that, go to the Serverless Lambda YouTube channel and check that out, or on Twitch. Really interesting conversation on how do you do. We're not trying to shove an entire pipeline of machine learning into serverless, but we're looking at inference, and we talked about how do you do inference, and there's several templates that have been built to help do that. So I encourage you to check that out. A couple of new launches. What's new in serverless? We have the AWS Lambda SAM launch. Again, these machine learning templates, these inference templates, so you can just SAM init, choose Python 3.8. And then you'll have 4 or 5 different machine learning templates that you can use. I don't know if you're following. Are you familiar with DynamoDB Accelerator? Have you ever used that, Julian?
I haven't used it, but I'm aware of it.
Super cool product, and it allows you to. It's basically a transparent cache in front of your DynamoDB. Now, DynamoDB is already fast, but if you need super low latency cache and again transparent, the accelerator or DAX is great, and it now supports encryption in transit of data between your applications and DAX clusters and between nodes within a DAX cluster. And then the biggie, and we're going to be talking about this. You're going to be talking about this next week. You and Dan Ronald, right? Yeah, this is a huge one. And our colleague Ben Smith has done a lot of information around this. Ben's a great guy. He's just smart. Now he's watching Feedy Ball right now, but he is a really smart guy. And he's put out a lot of things about the new Workflow Studio. And this allows you to build step function workflows visually. You just drag and drop, design it. It's super cool. So we'll be demonstrating that and showing it next week. Julian will be hosting that. And then we have some blogs. Julian, your name's in here a couple times.
Oh, wow. That is cool. Yes.
Yeah.
Well, yeah, I'm doing a whole. I'll chat well away. Basically, if you're aware of the well-architected framework within AWS, this is a way that you can get information on our best practices for building applications, and there's a serverless lens component of it. And I'm literally going through every single question within the well-architected framework serverless lens and doing a bit of a deep dive onto all the questions that are asked and trying to hopefully bring the guidance to light and showing that. So at the moment, we're talking about application security boundaries. So I'm talking about things like least privilege and IAM roles per function, and how to audit your so using CloudTrail, and how to audit what your actual permissions are in use. So there's blogs hopefully coming out every week or so as I continue the series.
I love this because like any other technology, while you may have your application working, is it working as well as it could and as secure as it could? And Julian, who, don't let the long hair fool you, he's really smart. Actually, I guess long hair has something to do with that. But don't let the mention of feet ball fool you. He's very smart, has done a lot of breakdown on this, and really knocks out the park here. We've got several other blogs that are out there. James has a series on his AlleyCat series, and this is on monitoring and troubleshooting serverless data analytic applications. James did a lot of work around building a leaderboard and lots of analytics going on. And he's got a good grasp on how to build these things out. So this blog series is great. Again, we the deploy learning models with serverless templates. And then more on the building leaderboard from James. All kinds of blogs. And then prototyping at speed. Again, we're going to talk about the workflow studio next week, and Ben Smith's blog is out there. If you want to read these and a lot more serverless blogs coming out, I encourage you to go to s12d.com/serverless blogs.
Yeah, I just wanted to pick up on actually the GitHub Actions post, because I was involved with helping sort of shepherd that through.
Yeah,
that is such a cool.
I apologize.
Yeah, not at all. That's just such a cool, simple capability. GitHub Actions is a CI/CD pipeline which runs natively on GitHub, and you can use SAM, AWS SAM, Serverless Application Model, to build, deploy, test your applications. All you do is add a file into that, which gives some build steps. Commit that file up to your repository, and GitHub Actions runs a CI/CD pipeline automatically, does whatever testing you need to do, and then does the SAM deploy in the end. So literally, it's a hosted CI/CD pipeline, and the GitHub Actions running in GitHub can install SAM automatically. Super cool, easy way to get CI/CD up for your serverless apps.
CI/CD is a lot of times one of the biggest challenges, not just serverless, of anything, right? All right, we built our app. Now, how do we get it out there? How do we get it automated? I talk a lot about CI/CD, and I'm hugely excited about this. A lot of work's been put on this. In honor of Sam, I put my little Sam up here in the corner. I can't point at it. There you go. I put my little Sam up there in the corner. So, all righty. Excellent. Well, there's a couple series out there we've talked about and alluded to. We encourage you to check out. If you're not familiar with AlleyCat, James's series, phenomenal. James is I think he's probably producing a blog right now. If there's probably 17 blogs will come out from James today.
While he's sleeping.
Yeah, exactly. I'm pretty sure when he goes to sleep, his wife takes over and writes them, and then he gets up, and it's just a continual process. So, yeah, he's a monster writer. Sometimes we console ourselves by trying to say they're not good, but they are good. So I encourage you to read those. Ben also turning out some fabulous stuff. If you're new to serverless, I heavily encourage you to check this series out. He breaks it down into what does it look like locally? What does it look like? How do we we did this on legacy? What do we do in serverless? Those kinds of things. So he really helps you get started understanding developing serverless. And then finally, if you're building serverless of any kind, our serverless patterns collection at s12d.com patterns. I just put out several more. I know, Julian, you've got quite a few out there where if you need to, hey, how do I do authentication? Here's a pattern. How do I do Cognito, or how do I do Lambda DynamoDB? Here's a pattern. How do I do this crazy new, HTTP directly to Event Bridge? Here's a pattern. So the patterns they come in SAM, some of them are in CDK, and they help you get started. So it's not just learning about it, it's hands-on, drop it in, and off you go. All right, so let's get to today. We are going to be talking about AWS Lambda extensions, which are now in GA.
They are
Julian?
super exciting. Yeah, it's not quite AWS messaging and events, even though everything to do with Lambda is events. So we got the best of both worlds. We got the base world.
That's right. Yeah. That was my bad. That was completely my bad.
I'm joking. I'm joking. So AWS Lambda extensions. I'm just going to share my screen and just not to have too many slides up, but it's worth explaining some of the background with extensions, which I hope will give you a bit of a sort of bigger picture of why we built these, what they can do, and some of the cool functionality with it. But I've got loads of demos. We'll try and get through as many demos as possible. They're all going to be live. So I have been praying to the demo gods that they work. If not, well, who knows? It's the way it is.
So we're going to see some code.
We want to see some code, absolutely.
All right, very cool.
So Lambda extensions, the whole idea of Lambda extensions is it's a new way to easily integrate Lambda with your favorite tools. And they can be things like monitoring tools, observability tools, security, and some governance tools as well. So new way to integrate with the Lambda execution environment. And Lambda extensions is basically a bit of code you run next to Lambda to help you with your functions. Now, obviously, if you think of this as maybe something like observability, where you used to have a VM or a container or something that would have a long-running process. So an agent or a sidecar or something would start up, and that would just keep running through the whole time that things run. Well, Lambda that doesn't work particularly well because we have short-based invocations, and you don't want to have a process that keeps up and running all the time. So extensions is built in a way to be able to have these short-running processes and still have this cool functionality to be able to run these kind of agents. They're super easy to install, to configure, and very little operational overhead, which you'll see in the demos. And most importantly, for the code I write, is it helps to reduce the function code, which when I'm writing stuff is something
Amen, brother.
I certainly want.
Yeah, I hear you. I've always said the most dangerous part of my app is my code. That's the most brutal part. So.
Absolutely. Now, so some of the use cases, I was talking about observability. So this is capturing diagnostic information. The cool thing about extensions is they can actually start running even before the function starts invoking. They can run during the function invocation and then also do some activities after the function invocation is finished. So it gives you a lot more sort of rounded information that you can do about your how your functions are running. You can automatically instrument your code. So this is a cool thing. No need to do a lot of code changes to get some more stuff in your code. You can fetch configuration settings or secrets before the function invocation. I've got a cool demo to show that. And also some security agents can have a bit more insight into your Lambda function and alert you if anything funky is going on. So just talking about when I was talking about the invocation lifecycle, this is basically how the extensions work. They only run when there is something to do and not sort of run needlessly when there isn't something to do. And they can also continue to run after the function invocation is finished. And this is for maybe like sending telemetry data out about the invocation to some sort of observability or monitoring platform. And as I said before, they can initialize and work before the runtime starts. And then they've also got some time right at the end before Lambda shuts down to perform some cleanup tasks. Now, the really cool thing about extensions is this isn't just built within a vacuum just for Lambda. And, we know you've got a huge bunch of systems that you may need to manage. And, maybe you want to use a single tool across all kind of things. But, before serverless was maybe a little bit unique and you had to do some different observability or monitoring or have different processes for something like Lambda. And so Lambda extensions is designed to support the tools you already use to observe and operate Lambda functions, being simple to configure, which I'll show you. So, just to highlight a few, you've got something like App Dynamics just at the top left, and this has got auto-instrumenting of Node or Python code. CloudGuard provides zero configuration security. You've got Datadog, you've got Dynatrace, Epsilon, all these really famous companies that you probably already, or quite likely already using in other parts of your stack. You've got things like Lumigo, which has got some new functionality with extensions. HashiCorp Vault, so many people using HashiCorp Vault. And this extension makes it super easy to manage secrets and make them available to developers to use within their function code. And the cool thing is, which I'll allude to later, is you don't actually have to make your functions Vault aware. This is a cool cool way that you can simplify your functions and not have to have a whole bunch of CLI kind of things. So lots of partner tools. The idea is that if you're using something for containers or VMs or on-prem even, you can now use the same tools with serverless. AWS is also, yes, Eric.
No, I was just going to say, we've done some internally as well.
Absolutely.
I'm just jumping the gun. So, yeah.
Not at all. Please jump the gun. So, we've got AWS tools, which are also using extensions, AppConfig, which I'm going to show, Code Guru, Lambda Insights, which I'm also going to show. And then also, if you're wanting to use an open source tool for your telemetry, and maybe you've been looking at Open Telemetry, well, there is ADOT, which is the AWS distro for Open Telemetry, and that also has a Lambda as a Lambda extension. So, lots of different ways that you can use extensions. Quickly, just there are sort of three different I suppose aspects of extensions in a broader picture. There's how you can use them. That's just plugging in a tool like Dynatrace or Datadog into your extension. But you can also write your own extensions. So maybe you've got some custom tooling that you need, or you've got your own way that you want to get some cool information about Lambda. I've been working with one of our customers recently who's got a cool thing where they have an API, and one of their compliance requirements is when anyone hits the API, they need to do some logging and they need to do some stuff behind the API to prove who's been hitting the API. Well, with a synchronous invocation with Lambda, that's going to increase your response time. So what they're doing, they're building an extension. Lambda can quickly respond to the front end, and they can do all that sort of analytics and all that data gathering on the background. And they're building their own extension to do that. And then last is the logs API. Yeah, that is a super cool use case. I hope we can be able to talk more about it if they're able to do that. And then the logs API is a cool way that you can actually grab logs directly from Lambda. So what I'm going to do is I'm just going to actually, while we're here, I'm just going to post those 3 links because there are 3 blog posts. Hasn't brilliantly come up, but those are 3 blog posts that I wrote, which goes into a whole bunch of detail about that. In order to deploy it,
we just had a request for the blogs on the screen, and that's all the ones that were on the screen, right?
Ta-da! Yeah, there we go.
Perfect.
There we go.
There you go.
To deploy an extension, you use a Lambda layer or include it in a container image. And basically, extensions are just files in the Optics extensions directory. Lambda spots any extensions are there, runs them, and off you can go. So, much ado, let's actually see an extension in action. Or in fact, let's not see an extension in action, but you're going to see an extension in action. You're scratching your head wondering, what the heck is he talking about? But let's go. Let's see, I'm on the screen.
Accent's throwing me off.
I have a Lambda function, which I have very cleverly called test Lambda insights. I have no Lambda layer added. This is just a normal Lambda function, which I can test and I can run. So we are streaming a bit, so sometimes it does make things a little bit slower. And this just does a normal Lambda function invocation. Well, what I can do here is I can go to the configuration of the normal Lambda function under monitoring and observability tools. I click on the edit button. And what I can do here is just enable Cloudwatch Lambda Insights. So what I'm doing, enabling Cloudwatch Lambda Insights. And if you were keen and read this, the Lambda console adds a layer to your function and uses Lambda extensions to do that. So what I'm going to do is I'm going to save that. Once that Lambda function is saved, and we're going to be doing a bit of waiting, unfortunately, because my browser is a bit slow with while streaming. And what I do is I'm just going to run a few tests of this Lambda function. Now, actually, in the background, Lambda Insights is using Lambda extensions. And remember where we saw that layer? There was no layer before. Well, the console just added a Lambda layer. And you can see here the Lambda Insights extension with a version on. And yet we're up to layer 14. So this is how you can think of, Datadog, Dynatrace, or whatever. They just add a layer, or you can add a layer to your Lambda function, and you don't really need to know anything else. This is cool because it's just adding it on your behalf. And yes, you could build this into your process. So if I then headed over to Lambda Insights within Cloudwatch, and I go directly there, I did a few function invocations, so I can just do a refresh. And basically, Lambda Insights is now able to pull more information out about your Lambda functions than normal Cloudwatch Insights could. And these things include CPU usage, which you can't see the name. Oh, there. If I move it over, maybe it does. And network usage. So CPU usage and network usage is not something that Lambda by default is able to get you. But with Lambda Insights, because it's using an extension, it's got way more hooks into the Lambda environment. And so that can grab CPU usage and network throughput. And there are a whole bunch of other kind of things. So you're using an extension, but you don't even know it. And all of a sudden, you're now able to get some more info about Lambda that you didn't have before.
So the use case on this is I can go in, scroll up. What are the top metrics there?
Yeah. So, you've got your normal
invocations there, duration. Okay. All righty. So I had a question earlier this week. Someone hit me and said, what would be a good way to find out the duration of an invocation? This would be a great way to do it. Drop it into Lambda Insights. Sorry,
you can do. Duration is actually a metric that Cloudwatch automatically does for you without extensions. So you do have this, but the thing is, like network usage, if you are hitting a third-party API, you're paying for network bandwidth, or you're wondering, if you're doing cross AZ kind of stuff, you never knew that before with Lambda, or you'd maybe have to have for something in your function to do that. Well, Lambda Insights can get that automatically from you, and that could be useful.
Okay, so we have a question that came in, Julian. I'm going to throw it up here. It says, what trade-offs are there for enabling the extension?
Yep, certainly. So I wouldn't think about it as trade-offs, but maybe you can. That basically, I'm going to go into the Lambda lifecycle in a little bit and show you more about that. But basically, the extensions and the Lambda function run within what we call the execution environment, which is a bit of a secure bubble that runs your Lambda function code. So if your extension uses a lot of CPU or memory resources, that's going to make your function run slower. You fix it by adding some more memory. So that's the one trade-off you're going to do. There is processing that is going on. So you're going to need to add resources to that. And of course, if your extension is super resource intensive, it's going to take longer to run. That could have a cost consideration.
And you can use the insights, Lambda Insights, to see what your CPU is doing.
You can do. And there are even some more. That's why we need you. And so there are even more, some other more metrics which I think I've got a slide on to cover. So quickly, because I want to get onto some demos, there are actually two different types of extensions: internal and external extensions. Internal extensions just run as a separate thread within your code, and this can be used for things like Java and Node and whatever, and Python that you can just run an additional process. But external extensions,
Let me ask this question: talk to me about language. So can an extension be a different language than the function itself?
No, not necessarily. So in fact, I've got a slide on that which will maybe pick that apart a little bit easier because you can see why. Right. So I will certainly answer that question because there's a good bit about that. So just on the external extensions are actually completely separate processes. They still run within the execution environment, but they are completely separate processes. So internal extensions, these are a way that you can actually modify how Lambda starts the runtime. So if you've got Java, Node, and .NET for two different ways, language, environment variables, and wrapper scripts. And these are a way that you can actually impact how Lambda starts the runtime. So you can see the process boundaries there for the internal extensions. It's all within the runtime process, and your runtime and extensions sit happily together. So let's have a look at an internal extension. If I head back into my console, I have got a Python function over here. And what I want to do, let me actually I'm just going to run this Python function. And this Python function is going to do a test event. And if I was to go into Cloudwatch logs and look at that, you can see this has got, literally basic information. This is the test from the console. I'm just sending these 3 key values. That's it. Super exciting. Sorry about that.
It's a good design. I like it.
It is a good design.
Yeah,
now, what I've done is I've actually added within my function code, as I've uploaded it to either as a container image or zip, what I've done is I say what I want to do is I want to add these extra arguments when Lambda starts Python, add -x import time, which is a Python-specific environment variable that you can load Python, and it's going to give you some more information. So if you were running Python on a normal server or on your workstation and you wanted to see the import time for the different modules, you would just write Python -x import time, and you would get that information. Previously, you couldn't do that with Lambda because you can't SSH into a Lambda function and go, oh yes, when Lambda runs Python, add the -x import time. So now you can. So what we can do is we simply configure this via an environment variable. Let me just copy the information over here, and I've got a exec wrapper. That's the environment variable name, and all I'm doing is I'm just literally pointing it to that wrapper scripts. And I add that, I save my function, which goes off into the underworld of Lambda and does that. And now if I go and I just run another test function invocation, that's all succeeded. I'm just going to jump. This was the original one. Remember, not much more information. This is the second time the log runs. And look at this. We now have every single Python library that's done with the import time that has taken. So I haven't made any code changes. I've just wrapped the Python runtime with this wrapper script. And so when Lambda runs Python, I've told it to do some more stuff, and I could use this for troubleshooting. So the other kind of use cases, there's a good example for Java, for example. People are using a lot of Java dependencies, and then they're not quite sure which one has actually loaded. So you can do a similar thing for Java, not just import time, but you can also look at the exact path of everything that's launching for Java. And then you go, my path is not what I thought it was. It's actually this library running, not this library running. And it makes for a happy day rather than having to scratch your head and trying to work out how all these things are working. So that's an internal extension. Yes, Eric.
Well, I'll make sure I'm not confusing anybody else. I saw you add the wrapper. How is that an extension? Was it added through an extension?
Because it's an internal extension, you can just add it as part of your function code. And so, yeah, it doesn't need to be added as a layer or in a container image. Because an internal extension is sort of part of the runtime, you can just make that part of your function code. So there are some slight differences. The blog posts go into it. I think we'd be here for hours if I had to go into all the nuances. But yeah, there are different deployments of where you stick these files, basically. Right.
No, and I just want to make sure we made that clear is how those work. We do have a question coming in here. Nope. It's just a statement. Some Java information for Java uses HTTP4K, super lightweight, no dependencies. Cool. I'll take your word on that. I can't even spell Java. So unless it's Java moving on to script. So there you go. But so there you go. All right.
So external extensions are what we were talking about before in the bigger kind of picture, where basically they run as these separate processes. They can start before and start afterwards. And when you're talking about a different language, because they are different processes, extensions can be written in a different language because it's not within the same process.
Gotcha.
So a cool thing you can do is you could have an extension, and if you write it as a self-contained binary, so in something like Go or something that's self-compiled, you could then use that extension with any of the other runtimes. Because it's a binary, you could have a Node function, a Python function, and a .NET function, and that same executable binary written in Go, because it's self-contained, can run the extension. So that's a really cool thing, that you could have a single extension which you can use across all these different runtimes.
Okay,
they're the process boundaries that you can see over there. So I've got a cool demo to show how to use a external extension, and it uses something called AppConfig. I'm not going to go into all the things of AppConfig, but AppConfig has got a really cool way that you can manage application configuration information, similar to what you can do with Parameter Store or Secrets Manager. But what AppConfig brings to the party is it allows you to have controlled deployment and validation. So you can do some whole bunch of clever, funky kind of stuff where you can run Lambda functions before and afterwards to say, let's check this deployment has worked, roll back the deployment, all that kind of thing. So it's not as simple as having something in Parameter Store, you then change that parameter and oops, you've broken something. AppConfig gives you a whole bunch of robust deployment stuff to do that. And they have written a AWS Lambda extension, which basically caches the information from AppConfig and makes it available to a Lambda function. So let's see how that works. If I pop over to this kind of screen and I head back, basically I've pre-deployed this. It literally only takes a minute, but it's basically a SAM template. Before that, what was I going to show is I was going to say there is a GitHub repo, which I'm going to post into the chat, which contains this and loads more really interesting examples for extensions. So this AppConfig extension demo is within here. You literally do if I go up on my history, it is literally SAM deploy, stack name, and it goes and deploys the whole thing. Everything to do with the AppConfig. So these are really cool demos that are super easy to get going. You don't need to know anything about AppConfig. You probably need to know very little about Lambda to get them up and running. But yeah, these are super easy. And all it basically says is, you know what, when you build this Lambda function, add this as a Lambda layer, and that's going to do all the AppConfig stuff in the background. And you can see here, if I just click back, probably in the time I would have done this, wrong window, this would have deployed anyway. I thought it'd be quicker. But basically, this SAM template is just going to deploy a whole bunch of AppConfig stuff, some IAM stuff, and some Lambda functions.
Right.
So if we then go into this particular Lambda function, which has the AppConfig layer added, that was that layer 44. What I'm going to do is I'm getting lost in my zoomed in console.
Yeah, it's hard. Yeah.
What I'm going to do is I'm just going to run a Lambda function. And what this is going to do is basically it's going to pull a value from AppConfig. And what I've done is in AppConfig, which I'll show you shortly, I'm storing a log level of normal. So the Lambda function code, which actually we could look over here, which may bring us to a little bit to light. As this whirs over, the code is simply going to say, that's the extension. Where am I going? No, that's not the extension. This is, sorry for jumping around. Basically, this all this Lambda function is going to do is it's just telling me, is it a cold start? And it's pulling a log level from AppConfig, and it's actually doing it via a local HTTP call. So AppConfig runs as an extension, and the Lambda function just does a local HTTP call to this little Go web server that's running to pull the AppConfig configuration. No AppConfig CLI, SDK, or anything needed within this Lambda function. So if I go back to my test and I had this execution, this was a cold start and the log level was normal. If I was then to, sorry, let me jump this again. Test button has moved around since last I tested this. So next time, so I've run this Lambda function again. Look what's happened. I've still got the log level normal, but this is a cold start. So basically, Lambda's just running from a warm start. And of course, but I've got the same log level. Boring. Let's see what we can do. So now I'm just jumping literally into AppConfig, and we don't need to really concern ourselves with all this detail of AppConfig, but here's basically where I'm storing this log level of normal, and this is what the AppConfig thing is pulling. So what I'm going to do is I'm just going to create a new version, and I'm going to do verbose logging. So pretend I want to then change the way I'm doing logging, and I want to do it centrally via AppConfig, and I'm going to then do this. So what I'm going to do is I'm going to deploy this change out via AppConfig. I'm just going to say I can do it all now, but this is where AppConfig can go mad and can have a whole bunch of tests and everything that can do that. I'm not going to do that. All I'm doing is I'm going to deploy this new code change out. It's going to be very quick. It's telling me I've got a configuration number 2, which is that verbose logging. So I'm going to now head back to my Lambda function, and I'm going to test again. Let's see what's over here. And test again. Look here. Look what's here. My log level is now verbose, but I'm still not having a cold start. So Think of it. If I was doing this in a Lambda function and I was changing maybe an environment variable, I would have to go to a whole bunch of Lambda functions and change the environment variable. That would redeploy the Lambda function. The next invoke would be a cold start to get the verbose login. With AppConfig, I've changed basically a setting within my application while it is still a warm start, no cold start. You think, okay, for one Lambda function. But can you imagine you've got some scenario where you've got 100 or 200 functions involved in some kind of thing? You make that change centrally, and on the next invocation of every single Lambda function, even if they're a warm start, you get the updated value. I think that is super cool.
It is, and here's because the alternative would be, one, make the change in every Lambda function, redeploy every Lambda function, right? Or two, store it someplace that the Lambda function, sorry, Chris Munns, please forgive me. The Lambda function has to pull for that every time. So your other option would be stored in something like a secrets manager or something like you see the S3 bucket, and then every time you invoke, you have to check for that value, and that's costly and first in time and money. Right? Exactly. Yeah. So, but with this, what you're saying is, I'm going to have a Lambda function and attach to it out of the same in a separate process, same execution environment, separate process. It's going to check for that change. And you can set that timer, right? You say every 5 minutes check for it or whatever. And that may have been what the delay was there. So it checks for that, and then it presents to the Lambda function itself a little API that the Lambda function invokes very quickly. So rather than calling Secrets Manager, calling S3, it's just calling an internal process that's very quick, and it'll get that update. So and you don't need to have any code within your Lambda function to even talk to AppConfig. It's just a local HTTP call. So that also removes even some of that code you need to have. Yeah, super powerful. And this is when you start thinking, we've got a couple of questions we're going to jump to here in just a second. This is when you start thinking of, I'm no longer building proof of concepts. I'm building scalable, manageable applications. Right, so I think this AppConfig is one of the coolest ones out there, because I can configure my Lambda functions with this perfect balance of not having to invoke every time, but not or check it on every invocation, but also not having to redeploy every time. We have a couple of questions, Julian, I'll jump to, unless you want to add anything real quick. No, I just wanted to say, I mean, we're using a contrived example just for a log level, but there could be loads of application settings that you want to do. And the cool thing about AppConfig is you can do those tests. So you can literally have, roll it out. It will, do a test. If the test doesn't work, it rolls back automatically. So it's like, the deployment checking is really cool. Yeah, and that's a quick turnaround, right? That's that's not oh my gosh, I have to go back and redeploy 300 Lambda functions. That is, let's toggle that feature back. Worst case scenario, depending on the timing of our actual extension, and let's say we check every 1 minute. Worst case scenario, you're out of sync for 1 minute, or 5 minutes or whatever. So one of the questions we had, go back up here, Jones, Zachariah, Noel asked, can we have internal Lambda to only log for a specific version or alias? And I might need a little more on that one, unless Jones, give us a little more on what you're trying to ask, and then we'll see if we can answer that, because I'm not exactly sure what you're asking. All right, we have another one down here from Venkatesh88. How can we do different stages with different configurations? So, I mean, this is just part of the AppConfig. You would then probably have different Lambda functions, which would point to different AppConfig configurations. And you can sort of do canary deployments, and you can do weighted deployments. And there's a whole bunch of kind of stuff. So I think that gets more onto your sort of different stages and different configurations, and have different Lambda functions that you want to manage as part of your application lifecycle. Exactly. We had another question coming up here, and I'm going to find the answer really quick here. All right. So, so we have this statement from Fascinating. Finally, no more multiple environment variables updated. Yeah. I mean, that's a cool way. You're starting to see the power of what's going on with that. And Julian, I don't know if you have this off the top of your head, but how does Extensions work with pricing? If it's running, pulling, AppConfig all the time, would it essentially be a normal web server? Well, the cool thing is it's not actually running all the time.
So you may realize that once a Lambda invocation is finished, Lambda freezes the execution environment waiting for another invocation. If another invocation comes in immediately, it's just going to run as a warm start. But what happens with extensions is the extensions freeze as well. So in that example, if there are no pending invokes, Lambda will freeze the execution environment, including the function and the extension, sits there, doesn't do anything, doesn't cost you anything. When the next invoke comes in, it unfreezes the execution environment and just carries on where it finished. AppConfig in that example will look at the time and go, "Oh, I need to do another check. It's been more than 5 minutes or more than 1 minute or whatever." We'll refresh that information, and then the Lambda function can run.
Right, and so your cost incurs there might be, and again, this is why the extension helps. So there's a cost to incur on polling AppConfig, right? And
yes.
so rather than,
but you're not paying for the cost of the AppConfig extension running all the time in the background.
Right. So again, let's go back to our scenario. I have 300 Lambda functions. If let's say I kept something in AppConfig or secrets manager or something like that, I'm making a call, invoking that API, incurring a cost, every invocation, every Lambda function, every time they go. Rather, this time I'm going to grab that extension, is going to grab that data, and then the Lambda will just invoke against the extension over and over. And so I'm not calling AppConfig over and over and over. So
correct, which is cheaper and faster.
Super powerful. Yep. Okay. Hopefully that helps out. I don't see any of the questions coming in.
Cool.
Do you have another demo you're going to do? All right.
We haven't got sort of a lot of time to go through the Lambda execution environment, so I'll just flick through it. So these are the APIs, extensions, runtime, and logs API. And there's a whole sort of life cycle with extensions. You can see here that's how the extensions start before the runtime. So they get going, the runtime gets going, and then the function runs, and then the function can do their invoke. And there you can see that freeze thaw process, which basically pauses all of Lambda, not all of Lambda, but your execution environment for your function between the. We pause it. We just pause it. Go for it. Sorry.
Right.
And that pauses it, and then you've got time after the invocation to maybe send some logs out, or maybe do some stats, or do whatever kind of thing. And then also when Lambda then shuts down the environment, this before you had no visibility into this. This would just happen in the background, and poof, the execution environment would go. Well, now you've actually got time for the extensions to shut down, to flush any final logs, to maybe close a connection to a third-party database or to an API or something like that.
This is a great. Go ahead.
No, carry on.
Well, this is a great, throw extensions out for a minute. This is a great understanding of Lambda functions and how they init and the runtime and understanding that. And this idea that it's sitting there waiting, to pop up. And so now we're giving them this extra power of saying, okay, just a little bit before, we'll do some work, and then afterwards we'll do some cleanup work. And this is what makes those, connection to third parties super powerful. As well.
Yeah, and really easy. It's the third party who also writes the code, so you don't have to put a whole lot of code in your function. So just talking about the billing, here's where the billing works in. You basically pay for the time that your Lambda function and the extensions all run, and then Lambda's request served plus build duration, and then for the shutdown you then pay for for the build duration. And of course this is all in 1 millisecond increments. Super granular. There are some Cloudwatch metrics. I didn't stick that in a slide just for time. So there is another metric called post extensions runtime duration, which can tell you how long an extension takes above and beyond the Lambda function. So you could see what impact your extensions is having. And also, if you want to try for different extensions, you can always add and remove the extensions, see how long the function takes to run, add an extension, and work it out that way. So that's another one.
All right. So
yes, question.
So he did do some clarification, or he or she there, and Jones said, I have different Lambda aliases, dev and prod. Can we enable extensions only for a specific alias, or is it for the Lambda function and all aliases have the extension enabled? Do you know on that?
It's the same as with environment variables and all configuration of your Lambda function. So aliases point to specific versions of a Lambda function, and so yes, a version of a Lambda function let me just check. My brain's going a bit doolally, but different versions of different Lambda functions can have different configurations. So you could have different environment variables or extensions for specific aliases, or you could have the same one.
Yeah. I would push back, and I don't want to go too far off that, but I would ask, why are you using dev and prod aliases?
And this for versions.
Yeah, this is off topic a little bit, but it is a best practice statement that I'd like to throw out at you. We encourage you not to use aliases and versions for development environments, because they're little things. Aliases and versions are great, very powerful when we're talking, and they're automated when we do safety floors and things like that. But if you're doing them so that all developers can develop in the same account and have different versions, stuff like that, that becomes really tough to manage. We encourage, and I won't go too much on this, but we really encourage you a separate account for each developer. That way, they just use the Lambda function. They're not even worried about the alias and version. It's just, here's the Lambda function we use. And then each environment have its own account. And when you think cost-wise, you're actually, unless you're getting into non-serverless resources, there's a chance you might pay even less, because you're taking advantage of tiered the free tier across multiple accounts rather than piling them all up in one and overgoing that free tier. So glad to do more out of band on this. Hit me on Twitter at EDJ Geek. But I really encourage you, if you're using dev and prod versions and aliases all in the same account, you're probably doing a little more heavy lifting. It's kind of the word we use here, than you want to do. So
yes, that's why I think of the term versions before aliases. So you want to use the power of different Lambda versions, but it is different versions of the same function, and aliases point to those versions. So those versions, if you think of it as versions, that's a mental model of different iterations rather than dev and prod separate Lambda functions.
Good. Yep. We have one other question before you jump on. It said, is there a way to check how many times a Lambda is invoked?
Yes, there is. There are invocation metrics within Cloudwatch metrics, which will tell you exactly how many times a Lambda function is invoked, and you can graph and plot that to your HOTS content.
Right, over a duration of time, and that's in the standard metrics, right?
Correct. Yeah, you don't have to do anything for that. That just comes out of the box with using a managed service. So probably actually haven't got if you're building your own extensions, haven't got a huge amount of time to do this demo. But basically, if you're building your own extensions within the GitHub repository, there is this custom runtime extensions demo, and that is super easy. You also do a one-click deploy, and you run that. And this uses a custom runtime, so it has got a custom runtime, one Lambda function and two extensions, all sort of connected together. And what it does, the function just runs. And what it does is when it runs, I'll just look at the log stream. I think I'm picking the log stream. And what it does is it does a vast amount of logging. And so you can see here, this is the extension starting before the runtime. The runtime runs, the runtime sends that information onto the function. The extension does its bit, on and on and on. You can see all the logging that happens over here. Now, this is really cool if you're doing extensions, but a secret tip is if you actually want to learn how Lambda runs, this is a great little demo that you can do, because each step of the process from that timeline I was showing before is logged in huge, big detail. And you can look at the code and you can see exactly how a custom runtime works, a Lambda function and an extension. So if you want to sort of see under the hood how Lambda works, this is a cool, simple to deploy demo that can give you great insights into how Lambda actually works with or without extensions.
We have to throw out one caveat. Do not run this in production forever and ever without using the data, because that's a lot of storing and logging that you're paying for. This is for, and that's an important thing when we talk about when do we log. Yeah,
but to be honest, you could just deploy this function and run it once, and it gives you all the information. It doesn't even need to be something that needs to be redeployed. Oh, unless I suppose you want to see the shutdown events and see multiple invocations. But fair enough. But I mean, okay, you run it twice. That's within your million free invocations per month. I think you're going to be okay.
Yeah. Well, I'm just talking about, we have folks that'll store data. Yeah, we log everything. And that's great if you're using it. You know what I mean? Are you firing your alarms off and alerts and things like that? But, storage is storage. So careful with that.
I think I've got one more time to squeeze in another demo. I said I had loads, so we've got to go for it. So the last little bit of Lambda extensions is extensions can actually now send logs to custom destinations. So currently, and love Cloudwatch logs or Lambda logs get sent to Cloudwatch logs, but you may then have some other requirements. And so people have built these slightly convoluted Rube Goldberg machines to send the Cloudwatch logs via a Lambda function to Kinesis to another Lambda function, which pumps it into S3, which then does some analytics and all this kind of stuff. And yeah, that can be quite a bit of infrastructure that you need to run and paid for. So Lambda Extensions has got the Logs API, which allows you to basically have an extension that Lambda can send logs directly to the extension, and that can then send it to anywhere. I've got a demo here which sends it to an S3 bucket, but that could literally be anywhere. It could be to be a Raspberry Pi on your desk. It could be some observability tool. It could be heck, it could be anywhere. So this is a really cool functionality because it partly decouples the logging that Lambda Cloudwatch Logs does, and gives you just different options that you can send your logs. So this is a simple demo. It's just going to send the logs to S3. And again, it is within the same GitHub repository. There are two different versions. One of it is using the zip archive function, and one also using a container image format. We haven't had time to go into that today, but there is a whole slightly different way that you incorporate extensions when you build your functions as container images. But conceptually, it's quite simple. You just include the extension files within your container image, and you're done. If you're used to building Docker files, you're used to all of that, and that's simply how it works. In fact, I can quickly go and show you. Here's a Docker file, which literally just copies the extension files and runs a pip install to do that. And then there's another Docker file for the function, which goes use my container image layer as part to add the extension to the Docker image. This goes along. You can see here, because it's a function deployed as a container image, I've got no concept of Lambda layers because everything within the container image is in just one big image artifact, and that's it. So, of course, what I can do is I can just test this Lambda function. And again, this was a one-click deploy via the awesomeness of SAM, so it's really easy to test this out. I'm going to run a few invocations just for fun. And what is going to happen is in the background, Lambda is going to stream the platform and the function logs directly to the extension. The extension is going to batch them up. Now, maybe you've got some cool use case. You want to do some filtering. You want to do some analytics. You maybe want to send your billing logs to one system. You maybe want to send your function logs to another system. All these kind of things that you didn't have before with CloudWatch logs, you can build your own extension to do that. And what basically happens now is I have just these logs are just uploaded to S3 as a raw file, which I should be able to open. Let's see, I do have a downloads folder. Open with, sorry, I'm on another screen. I will send it over to you. And here we go, zoom in. And so this is in all the ugly beauty of a log file. I've got the platform start logs, which maybe I could then filter and send somewhere else. I've got the function logs, and just so this is a really good way, really good demo that you can see how you can use to send your logs elsewhere. There's another demo on the GitHub repository. If I can pop to the puppets over there, and that also has one to Elasticache. So if you want to send your logs to Elasticache, I can't find it. Anyway, so here we go. Python for Elasticsearch Logs API extension. So this whole GitHub repository has recently been revamped. It's got a whole bunch of extensions by Go, Python, Node, Java, a whole bunch of different logging extensions. And also it's got then open source extensions via Lambda Ready partners. So you can actually see, HashiCorp Vault, Honeycombs, CoreLogics, you can see their extension code. And this is all available from this repository. And it lists all the other Lambda partners. So there's a lot of information here just in the GitHub repo showing you all the beautiful stuff to do with Lambda extensions. Yep. So I've been talking a lot.
I don't know if you caught it, but we had Dan, NBA is keeping us up. England 2, Germany 0. So
thanks, Dan, NBA.
Multi-purpose stream here, so we keep you up to date with the stuff. And then we had, of course, TypeScript for tea time. Said good old Notepad. TypeScript tea time. There we go. Good old Notepad. So yes, Julian is our token Windows user. Actually,
James as well.
Too, so yeah, that's right. So
normally I use Notepad++, but somehow whatever I was doing, it just popped in Notepad. Seemed to be quicker.
So, man, a ton of great information here. Extensions. Last week we were talking about, and I think you and I actually talked about it later this week. We were talking about bringing, updating models for machine learning. And if you think about it, there's even a possibility there, rather than embedding it in a container or storing it in an S3 bucket, you could actually grab them periodically as well. There's really no limit to what you can do with extensions. There's a lot of powerful, ideas. And what you want to balance is, we don't want to redeploy our Lambda function all the time. Every configuration shouldn't change if we have a bunch to do. And we don't want to call a bunch of APIs on every invocation, right? So this really answers that. And we need access to things. We need to do things outside of the process to ship stuff off or collect stuff or prepare stuff. And so great demos, Julian. And I know you've done a ton of work around this. So really appreciate it.
It's been super useful. Now, I also want to just highlight the sort of simplicity aspect of this. I mean, I've shown you a lot about, all the different APIs and the Lambda lifecycle and all that kind of thing. But that doesn't necessarily have to apply to you. I would think most people would just use the capabilities of an extension like that Lambda Insights one with you, your Datadog, your HashiCorp or whatever. And you really don't need to know what happens under the scene. The way it's been built into Lambda, really deeply into Lambda, means all your observability tools, all that kind of stuff, they can do the hard work of the integration, and you just write your function code. And actually, I'm just going to bring up a screen here recently, because I showed that log extension demo, and you're thinking, okay, there's a whole bunch of code. This is the Lambda function for that log extension demo.
That's right.
It's doing nothing, really doing nothing. I'm not having to write a whole bunch of code within my Lambda function to log all that stuff to S3. That's all handled by the extension. So yeah, think of this as something sending logs to Elasticsearch, or pulling secrets from HashiCorp or AppConfig, or sending something to Coralogix, all these kind of things. My Lambda function here is super simple, dumb as anything, not in a pejorative way, but yeah, that's deliberately. And all the cleverness is happening on the extension side. And all I'm doing is maybe just adding a Lambda layer, maybe doing an environment variable config, and job done.
Right. And that's another thing to think about is, am I repeating code in a lot of different Lambda functions? And if I am, that's problematic. Well, maybe problematic is not the right word, but that's not efficient, right?
Yeah, we could make it more easily.
Right, exactly. All right. Well, with that, we are at time. We're just a few minutes from here, so I think we're going to wrap it up. I don't see any other questions coming in. I am seeing learned a lot. Thank you. Thank you much. So good information coming in. Next week, we are going to be talking about the workflow. Julian will be back with Dan Ronald, Workflow Studio. Oh, I heavily encourage you to check this out. It's super cool. It's worth how you doing? It's worth a watch. You believe they pay me to speak?
It sounds all official, but it's literally building step functions with a GUI. I mean, how cool is that?
Yeah, exactly. But the cool thing is, it generates the ASL. It generates the states language that you can use in a SAM or a CDK or something like that. So super powerful with that. All right, so as always, we encourage you to visit serverlessland.com, where we put these videos. This is the website. We also have the YouTube channel. This video is immediately available on the YouTube channel. Everything serverless is here. We the DA team builds this, supports this, adds to this. We have third-party folks that have added some stuff to the patterns. We encourage you to check out Serverless Land. Hit us on our Twitter handles if we can help you in any way. If we don't know the answer, chances are we know the person with the answer. So, Julian, thanks for joining me.
Pleasure. This was awesome. It was nice to be on the other side of I was going to say the desk, but we're actually the other side of a whole big ocean.
That's right.
But yeah, it's always cool to do these with you. Love doing service office hours. It's really great opportunity to chat to people individually. Bring your questions. We're here every week, available offline. There's a whole bunch of Lambda stuff. If you're interested in the life cycle or want to know a bit about Lambda, get in contact with me, Julian_Wood on Twitter. More than happy to help you have fun with your serverless applications.
Nice. And if you'll go to serverlessland.com, there in the events drop down at the top, you'll see office hours. That will talk about all the office hours coming up and all the office hours we've done. Do you know that we're at 20? I think 20. This is the 21st episode, right around there.
Wow.
So yeah, we've got quite a few. So all right, with that, we're going to sign out. I hope y'all have a great day. Stay safe. Julian, thanks again. And
Thanks for
we're
having
out
me.
of here. You bet.